You are currently the only person in this conference.
Yes, sir.
Yeah, I got it. Thank you.
Yes, sir. Yes, sir.
Are you able to hear me clearly, madam?
Yes, sir. Yes, sir. Your voice is very audible. It's clear, sir.
Right. Thank you so much. You just contact me, madam, whenever I have to start, then I can
Yes,
just...
sir. Yes, sir. Just 2 minutes, sir. Students are logging in. Maybe in another 2 minutes.
Right.
Sir, shall we start, sir? Yes, sir. Shall we start, sir?
Madam, it's to me?
Yes, sir. Shall we start, sir?
No problem. I'm ready, madam.
Yeah, okay, sir. Okay, thank you, sir. Jaypriya, ma'am?
Yes, ma'am. Wait, start, ma'am. Yeah. Hello and a very good morning, everyone. I welcome you to today's webinar on electrical and lighting. Design Tree Service Consultants Private Limited has collaborated with us and have put together an amazing series of seminars on various topics related to building services and structures. Design Tree Service Consultants is a multidisciplinary engineering consultancy company founded in March 2008 by dynamic and innovative professionals to build the gap between the ever-changing needs of the construction industry. They are one of the largest service providers in Southeast Asia, a consultancy with branches in Bangalore, Hyderabad, Vijayawada, Chennai, and Kolkata with a cumulative staff strength of 300 plus. Design Tree provides the professional and technical skills to plan, design, and supervise the construction industry of a wide range of services from conception to delivery, such as civil and structural engineering, public health engineering, fire and life safety systems, electrical engineering, HVAC, and IBMS engineering. To begin with, it gives me immense pleasure to introduce our very prolific guest of today's webinar. We are honored this afternoon by the presence of Mr. Mitra Shriprasad, who is an Associate Director, Electrical Services at Design Tree Services. After graduating from BE Electrical from Institute of Engineers, Calcutta in 1955, his expertise in the design of electrical engineering to design consultancy and project management for various IT park, industrial, power plants, residential, hospitals, commercial complexes, substations and data centers, etc. With 25 years of experience in electrical engineering, he is one of the key personnel at Design Tree Services Consultants as an associate director. His diversified work experience in different organizations, like in vice president in Eversafe Consultant Private Limited as a chief engineer in CMAC Consultants Private Limited, as a design manager in CANSIP India Limited, as a chief engineer in AR Consultants. We are very pleased to have here with us Mr. Mitra Sriprada today. On behalf of McGANS Ooty School of Architecture, I welcome you, sir. Over to you, sir.
Thank you so much, madam. And good morning to Mr. Dean and Mr. Dr. Sanil Kumar also, who was there on the call. So thank you so much for giving an opportunity to interact with your students. And I appreciate your efforts also in getting a technical knowledge to the architects. Basically, it is like engineering knowledge to an architect. So today's my presentation is also, I don't want to bore you by providing more and more electrical input, because always we know electrical subject is always a shocking subject to any architect or any other than electrical engineers. So I don't want to trouble you, or I don't want to bore you on the electrical aspect. I'm just presenting this particular presentation with respect to architect view, what to be looked at in the electrical system. So this is our major concentration. So anywhere, if you feel that as I have slipped out something where you are having a good interest to learn, I am very much open to you. You can just ask me what and all things more you want to learn from the interaction. We are very open to you, and I will start my presentation. This particular presentation, as I explained to you, it is a architect's view on the electrical system whenever we are designing a building or whenever we are designing a project.
Sir, so one request, you can switch on your camera for once.
Just 1 minute.
This would help
The
us.
third icon, sir. The third icon.
Yeah. You able to see me, sir?
Not yet, sir.
Yeah, just coming. I think its camera is taking it.
Yes, sir.
Okay. So am I visible, sir?
Sir, right now it is blank screen.
I think 1 minute. I think the setting which is okay.
Now it's clear.
You're visible, sir.
Wait. So before that, it is an electricity. It is an invisible subject, but you can't see that. Great. So start with the topics. What and all I'm just going to cover today. It's basically on how we approach on any project. When you are designing a building or when you are designing a project, what is the approach on the electrical engineering discipline, which I just want to run through or take through. So the topics, as briefly I will explain about, I will skip this slide because these are all I'm going to cover as a discussion topic I just provided here. So where is the application? Application for any basic, what we talk about on the electricity is two names which always you hear on the whenever we are designing a project. That is called LT and HT. What is an LT and what is an HT? LT is nothing but a low tension distribution supply. That is like low voltage distribution supply. And HT is called always a high tension distribution supply. So basically the distribution parameter, when we are talking about a project, first question will come whether this project falls under LT application or a HT application. So this is what the difference between the LT and HT. What is the line where you define whether it is fall under LT or whether it is fall under HT? So the line is called 75 kVA. If the load of the project crosses beyond 75 kVA, we will call that project falls under high tension distribution supply. So if the load is less than 75 kVA, so it is like a LT distribution supply. So on a project, when we are talking about where this HT normally comes in picture, where the LT comes in picture. So if you take any of our residential apartment, normally our loads will be between the 2 to 5 kVA, 7 kVA, 8 kVA, 10 kVA. So these are all falls under LT distribution. Similarly for the villas. Where it falls in the HT is whenever we are talking about a big commercial buildings like IT, ITES buildings, or a hotel application building, or a retail spaces and malls, or any institution buildings where the load is more than 75 kVA, it falls under HT distribution system. So this is basically the first term which we have to talk about is the LT or HT. This clarifies which the building falls under which discipline. So going on to the second slide is, so where this 75 kVA, how that, what is that, the basis for the 75 kVA is the load calculations. So what is the load calculations which we have to consider? What are the loads we have to consider within the electrical to get the final load of the project? So the internal, when we talk about, first I will take through the commercial, then I will run through the residential also. First, if I start with the commercial, normally you will see a lighting load. Lighting load is nothing but a building lighting load. Building lighting load is classified into within the tenant space or within the floor area or common areas and the basement areas, all those things. Second is a raw power load. Raw power load is nothing but a small minimum appliances load which comes for the maintenance activity, not for the regular your computers or any specific application load. This raw power load you can classify it as a maintenance load, which is, we will take it as a 0.25 VA per SFT. AHUs is the floor distribution where you have to feed all air conditioning requirements within the floor that will be supplied through an air handling unit. Last week, my colleague, Mr. Karthik Vibat, has explained regarding the AC distribution. So this is the air handling unit which serves the air conditioning requirements within the office areas or any floor areas. Next comes is the UPS power. This is a specific power requirement in terms of office areas. It is nothing but your computer loads or your printer loads or your server loads. All this falls under the UPS power requirement. When we take about the commercial malls and other things also, there is a specific lighting load requirement which need to be connected onto the UPS power, and all their emergency requirements need to be connected onto the UPS power. Then comes to the complete load analysis, the common area loads. These are the common areas loads, nothing but your plant loads. Like you are having a HVAC plant, you are having a water treatment plant, you are having a sewage treatment plant within the project. My colleagues next will talk about the plumbing requirements you will come across. You all will come across the water treatment plant and SUP plants and all those things, along with the lift requirements within the project. And all this falls under the common area loads. So normally any commercial building today, whatever we are designing, a benchmark, we take it as a 8 VA per SFT. So what is the power? If suppose somebody tells I am designing a commercial building of 1 lakh square foot area, so immediately as an architect, you can envisage what will be the power requirement. Okay, going into the detailed calculations, electrical consultant will do, forget about it. Principally, you come to know what is the area, what is the power requirements to be considered. So the power requirement immediately you can yourself can come into picture, and you can say that 1 lakh into 8 VA per SFT is nothing but 800 kVA is the power requirement for 1 lakh square foot. So this is the power requirement for which you have to design your electrical distribution equipment, for which you have to create the spaces within the basement and floor areas. So going on to the next slide, similarly on the residential apartments. Residential apartments, you will be having two different loads. Here also one is apartment loads, second is a common area loads. How we classify as an apartment load? This will change from the state to state. Whatever I have listed today is a benchmark in one of the states. This may differ with Telangana, this may differ with Tamil Nadu, this may differ with Karnataka. So principally how the calculations can be considered, I have just defined here. So two ways of defining a apartment load. One, principally somebody says that every apartment should be 2 BHK, means it should be considered as a 4 kilowatt. Some other state says 2 BHK should be 7 kilowatt load. These are the loads which they will specify on the paper. One way of doing is taking those loads, plugging into the load calculations and do the calculations according to that. Second way of doing it is few of the states are giving permit to design the load of the residential complex based on the actual energy study on the hour load basis. See, if you take a residential apartment, you take any residential complex, the peak loads will be in 2 times. What are those peak loads? Morning 6 to 9, evening 6 to 9. These are the peak timings, basically, where morning 6 to 9, where your kitchens or your geysers or your all those utilities comes into picture within the apartment. Evening 6 to 9 is your lighting load and your again cooking requirements and again some whatever the air conditioning requirement, all those comes into picture. So these are the peak timings. So hourly load analysis will give the average loading on the apartment. What is the average load to be considered on the apartment? So this average loading can be considered depending on, and it is not allowed on all the states, especially when we talk about the Tamil Nadu State Electricity Board has already defined what is the loads to be considered on a 2 BHK or 1 BHK or 3 BHK, 4 BHK in the TERC guidelines. That is the Tamil Nadu Electricity Regulatory Commission guidelines. So this is one typical calculation sake for which I have taken a 1 BHK can be considered with a 2 kilowatt, 2 BHK with the 4 kilowatt, and 3 BHK is with the 5 kilowatt, and 4 BHK is the 6 kilowatt. Principally, a question will come: what is the maximum load which can be to be considered within the residential apartment? So, what is the load to be considered? Everybody will immediately say, "Sir, air conditioning load." Air conditioning load is not the determinant factor for considering the maximum load within the apartment, because air conditioning load, once if you see that there is a set point of temperature, once the set point is achieved, your compressor will get switched off. So it is a on and off kind of application will happen. But the major principal load you have to consider is the geyser load. Geyser load is always a resistive load, which is always power consumption will be there throughout the set temperature achieved. So that is the geyser load is a predominantly for calculating the maximum demand on the apartment. Geyser load is the application which need to be considered as a peak demand load. Along with that, the common utility loads, you are all very well aware of it. Any residential complex will have a lift, will have a plumbing system loads like a water treatment plant or a sewage treatment plant or a rainwater sumps, rainwater pumping systems, all these things. And second, in basement and common area lighting and basement ventilation requirements. When we are going for a multiple basements, there will be fans located for the fresh air and exhaust requirements or exhaust requirement of that particular basement ventilation. So for those fans, we have to give the power. That is called basement ventilation load. And any residential complex will have a clubhouses. So the clubhouse will have air conditioning, clubhouse will have other facilities also for those clubhouse loads. And fire booster pumps. Here I just want to tell you, whenever you talk about the fire load, in case of any emergency, fire emergency, what will happen is the fire load, if you take it as there will be an electrical driven pump, there is an engine driven pump, there is a jockey pump, and there is a booster pump. All put together, a load of approximately 300 kilowatts or 400 kilowatts will come up if you sum up all those leads. But when a fire emergency happens, all other loads will get switched off. That is the rule of fire emergency. Your all other building loads will get switched off, and only fire equipment, firefighting equipment, plus along with one lift will come into picture. So whenever we talk about the fire loads, you should consider only the loads which are for the regular calculations, only the loads which are considered for a jockey pump or a fire booster pump, because these are will always on and off during normal time also to keep the pressure within the line. So whenever we talk about how we are arriving 2 kilowatt, 3 kilowatt, 4 kilowatt on any apartment, is the back end for that is the point matrix. So every room will have a point matrix very defined. What are the number of points which are considering within the rooms, like your foyer area, what is the points requirement, what is the living area number of points requirement. This is inclusive of lighting points and small power appliances points also will be defined very clearly. So this point matrix will arrive to do the maximum demand calculation on any apartment. So, okay, we talked about LT and HT. So LT, there is a line where we talked about 75 kVA. Once if you cross 75 kVA, we are falling under HT. When you are talking about the HT, so till what load? You will be hearing 11 multiplication table whenever you talk about the electrical supply voltage. it is multiples of 11. So 11, somebody will say 11, somebody will say 22, somebody will say 33 kV, somebody will say 66 kV, somebody will say 110 and 110 kV, all these 11 multiplications here. So which 11 I have to pick it up? That is the important factor. So till when we can use the what kind of voltage? So 11 kV voltage can be used up to what load, or above which what is the supply voltage need to be considered from the utility company is an important factor. So in terms of Tamil Nadu, when we define about it, till 5,000 kVA load, you can go with 11 kV supply. That is 11,000 kV is the incoming supply where utility will give it to you, like Tamil Nadu State Electricity Board will give it to you. From there, you will step down with a transformer to get the required voltage. Like whatever the voltage we will use within the house is nothing but 240 volts. You are getting 11,000 volts from the State Electricity Board. So there is a by means which you have to get from 11,000 volts to 240 volts that I will take through the next slide. But what will happen is the 11,000 volts till 5,000 kVA, whenever any consultant, electrical consultant, what is the power you are getting from the substation, you will specify till 5,000 kVA, you will get the 11,000 volts. Above 5,000 volts, above 5,000 kVA, above 5,000 kVA, we have to go with a higher voltage system. That higher voltage in Tamil Nadu is the 33,000 volts. It is 33 kV, it will be called as. For any voltage more than 11 kV, you require a substation. So if a project demands a load more than 5,000 kVA, you require a substation space. So that is where I'm just highlighting an architectural point of view. If the consultant says, electrical consultant says the load on the project is beyond 5,000 kVA, so immediately you have to identify a substation space within the project. So the substation can be defined in two ways. One is older way you are looking. Suppose if you are traveling to the villages or somewhere areas, you will be seeing like a substation is on the left side picture, whatever you are seeing, it is an open structure where you will be seeing a lot of poles and a lot of open-ended equipment, which will hamper aesthetics of your residential project. So the advanced developments, now what we are doing is over a period of time, the advanced developments of it has come on all engineering disciplines. There is a way of beautifying the substation space in conjunction with the architecture. So the right side picture is called as a GAS substation. GAS means gas insulated substation, which requires lesser space compared to a conventional substation, which adds more aesthetics to the project of add more aesthetics to the project. So this requires a less space and it gels with the architecture and it beautifies the project requirements. So principally on this slide, what I say is till 5,000 kVA, an architect doesn't think about any major space requirement. If the load exceeds beyond 5,000 kVA, definitely the architect has to keep it in mind. There is a substation will come into the project, and the substation, there are two ways of doing it. One is conventional, second is a GAS, and GAS may be a preferred way in terms of architecture. So what an electrical designer will give the input to the architects. Now I started with the substation. Second, I will talk. I need a transformer, madam. What is the transformer will do? That 11,000 or 33,000, whatever the voltage you are getting from the utility company, need to be stepped down to the required voltage at the apartment level. For doing that, we require a transformer. Transformer is a device which steps down from a primary higher voltage to a usable voltage which requires at the end point. So the transformers are required. So in case of any power supply failure happens within the project, like your regular shutdowns from the utility company, few things need to be done. Like your apartment, even the common area utilities like your WP, STP, or lighting or whatever it is, need to be backed up. For that backup power, we have to consider a generator, which is on the third picture. And fourth one is the inside the apartment or inside the commercial spaces, the lighting and small power requirements, external street lighting, whatever it is required, and panel rooms. The panel rooms within the ground level, at the ground level, to distribute the power to apartments or a regular floor loads. And on the top of it, each building, whatever you have designed, it has to be protected. The building structure is to be protected against the natural calamities. So again, anything like a lightning will happen on the building, because if you are designing a high-rise building, there is every possibility of hitting a lightning strike on a high-rise building. So the building need to be protected. For that, a lightning protection is required. And within the office spaces, whatever the lighting and small power, AHU, all that air conditioning requirements to be done. These are all the inputs which need to, a electrical consultant has to give it to the architect for the spatial design. So first I will start with the commercial design, then I will go on to the residential design. A commercial design, and just the requirements is, as I explained to you, if the load cross beyond the 5000 kVA, so you need to have a receiving substation, and even either 11,000 or a higher voltage, whatever the voltage, you require a transformers to step down from the supply voltage to the end users usable voltage. And for any power failures or for any emergency conditions, a backup power to be considered, that is to the DG sets, and a panel rooms to be considered for the floors distribution, apartments distribution at the ground level for distribution of power to the floors or tenants. So where to be located? Now I'm talking about the receiving stations or transformer areas or panel rooms or the DG sets. What are the ideal locations? So the receiving station, whatever it is called, is a main supply which you are getting from the utility company. So this receiving station, the principle is it should be immediately accessed to the authorities. It should not be through a controlled spaces. Like if I keep this utilities receiving station at the back end of the project, so the authorities has to pass through your security gates. So whenever you are applying for the authority connection, what the principle says is none of the authorities should be stopped or screened whenever they are going for the maintenance activities. So what we have to do is this receiving station should be next to the entry and exit gates, where a direct wicket gate will be given for the authorities maintenance or meter readings or whatever that it is required, and they should not be screened or questioned or none of the security staff should be stopped. So this is the receiving station. The principle is it should be next to the entry or exit gate. Next, I talk about the transformer. Transformer, yes, this has to gel with the architecture of the building. The transformers should be located, if it is an external outdoor transformer, whatever you are seeing, this is the transformer on the top view. So this is how the transformer yard looks like, and it should be beautifully screened in front with the architectural elements. But principally, this is an open transformer yard. It should be next immediately to the load centers. Why it is next to the load center? When you keep it a very far away place, the cables or the connectivity system should be done between the transformer to the panel rows. So if you increase the distance between the load center to transfer area, ultimately you are increasing the losses within the system, and you have to provide infra carriers up to the panel rooms, and which increases the ground your landscaping areas also, which affects your landscaping areas also. The better preferable location is at the ground level, above the ground level, and as per NBC also below the trafo area. Any outdoor transformer yards which you are keeping it below the trafo area, your basement should not come, or your basement should be isolated. The main basement which is below the trafo yard should be isolated. This is very much given in the NBC 2016 codes. This is how the external trafo yard looks like. So few of the architects will come and say, no, this looks very ugly in front of my building, where what I can do. So there is another method which is defined in the next slide. This is called a indoor trafo yard. Indoor trafo yard is now that whatever the external element you are bringing within the building, inside the building. So this you can brought within the building, but the type of transformer will change. Earlier, when you are talking about the outside transformer, it is an all-type transformer. But when you are bringing within the building, oil should not be there, because oil is a dangerous device. If you remember, one of the incident has happened in the Delhi Delhi, in one of the theater, what has happened is when the load exceeds beyond the thing, the oil will get heated up, and there is a possibility of damaging the core and shell. And once the oil spills out, it will be at a very higher temperature, and it will get a very havoc situation within the near vicinities. If a person is near the vicinity, there will be a oil bursts kind of. This is what the incident has happened in one Delhi theater. After that, what may happen is whenever a transformer you are installing inside the building, it should be dry type transformer. It is not. It should not have any oil within the transformer equipment. So this is called a dry type transformer. You can keep this in the ground level. Tamil Nadu, all the electrical installation should not go below the ground level. But other states, when you are practicing for the other states, all other states, your electrical equipment should be limited to the basement one level. Even you can keep these dry type transformers in basement one without any problem, but sufficient height is required, whatever for the transformer to move within the basement one, or otherwise to move within the ground level. You can definitely look at this principle where it is a very clean installation and you are seeing only external a landscape, beautiful landscaping. Other than that, all electrical equipment except that receiving station. Receiving station definitely I cannot bring in because it should be immediately accessed to the authorities. But whereas this can be brought in so that you can see a beautiful landscaping all around the buildings. So this is one of the principles. So when we are talking about the transformers, you can keep it outside. When you are keeping it outside, it is a oil type transformers. When you are keeping inside the building, it is a dry type transformers. Similarly, we discussed about it. There is a backup power will be supplied through the generators. The generators, you are seeing it. It should be kept. Again, the two types of principles. One is you can keep it outside, or you can keep it inside. So outside, whatever you are seeing is the picture, whatever it shows is the generators are located outside the building in the setback areas. So there the generators, when you kept outside, there is the thing is the generator sizing is good and it requires it generates lot of noise levels. So when you are keeping outside the generators, few things what you need to keep in picture is one, noise level, because all pollution control board says that what is the noise level to be maintained during the daytime and nighttime across your border of your project. So at the compound wall level, what is the noise levels to be maintained? So that is the cons which you have it. But when I talk about the pros, the positiveness of it when you are locating outside is any generator requires a fresh air to breathe in and it delivers hot air outside. So when you keep the generators in the basement, what you have to give is again you have to put up some pressure into the basement, and the hot air, whatever it is coming out from the generator, should be exhausted above the ground level. That is the when we talk about the outdoor installation, this need not to be thought in because it is above the ground level and it is exposed to the ambience where the fresh air can be breathed in from the naturally from the atmosphere and the hot air will be discharged naturally to natural ground level. That is the advantage of the locating the gensets at the ground level. But cons, I will explain you one. That cons is the noise level is one. Second thing is whenever you the any DG cell, any generator, you will have a flue pipe. That flue pipe has to be that is like a sulfur dioxide content will come whenever you are burning the fuel, like our car only. Whenever we are burning the fuel, backside you will get the smoke. Similarly, this is the kind where whenever the generator is running, you will get the black smoke. That is called sulfur dioxide content. That sulfur dioxide has to be emitted as per the pollution control board norms above the building level, or it should be a self-supporting stack which need to be calculated based on the rating of the generator. So two ways of discharging it, as I explained to you. One is above the building level. When I'm keeping the generator outside, you have to connect the generator flue pipe to the building external facade by a bridge, and then you take to the top of the building. That is one way of doing it. That is depleted in the second. That is shown in the picture 2. Or otherwise, go with a self-supporting stack, which can be exhausted above the based on the rating of the generator, based on the calculation, which need to be done as shown in the picture one. This is the picture one is a self-supporting stack when you are talking about the outdoor generators. Picture two is connecting to the building and leaving above the terrace level. So the first picture, when you see it, definitely architect won't like it. What is the structure in front of my building or wherever I'm seeing this looks ugly. So a few things has come up. You can just clad all around this exhaust stack as a you can just say as a facade element where you can just highlight about the project, or you can just keep the logos of the individual tenants or otherwise the company logo or a building logo, whatever, you can just keep it on this facade one. This is about the outdoor installation. Okay, next, anyway, I'm taking through the indoor installation. No, I don't want to do all these things. I want to have a beautiful installation. I don't want to see all these elements outside. Then the generators can be brought within the building footprint. In Tamil Nadu, again, the same principle, it should not go below the ground level. It should be above the ground level. But all other states, they are permitting up to the basement level. So this is how the generator can brought in within the building footprint, where you are seeing this is the generator location within the building footprint, and this is how the inside the generator room looks like to have to reduce the noise level. All this is acoustically treated, and noise level will be reduced. And the third picture shows this is how the fresh air and exhaust requirement. The fresh air is brought in from one side, and the hot air will be thrown onto the other side. This hot air should be thrown outside to the natural atmosphere because the temperatures will be very, very high on the hot air side. So it should be left above the ground level where the human interface is not there, or above the human interface. So this is the third one which I had just talked about. We have talked about the receiving station, we talked about the transformers, we talked about the generators. Now, that fourth point is the panel roofs. So the panel roofs, as per Tamil Nadu, again and again, I am repeating the same thing. None of the electrical installation should go into the basement. It should be above ground level only. So the ground level where we can see in the picture, it should be above the ground level panel roofs. And the second picture shows, and other states it is allowed, and as per NBC 2016 also it is allowed into first basement level, so the basement level. The ideal location of the transfer room, the panel room should be, it should be at the center where your distribution will be very, very less. So if it is at the center level, it is next to the course where your vertical distribution loads are very immediately addressed, and the WTP, STP loads, if you are throwing out to all four corners, and it will be centrally, it will be distributing to all four corners. If you take it onto the one side of it, and if you are distributing the loads to the other side of it, it calls for a huge infrastructure where you have to run more numbers of cables, and the cable trays all will be looking very, very, very ugly within the basement areas. So next is similar type of what we have to consider, the four principles on the residential design. Residential design, the four principles remain same like your main receiving station. There is no change, either it is a commercial or a residential. The main receiving station should be next to entrance and exit gates, and transformers. Next is comes to the transformers. This is how the transformers will be. The residential applications, what will happen is when you are handing over, because these are all will build, it is a principally first I say LT supply. LT supply is owned and maintained by the authorities. So you have to build the infrastructure and hand it over to the authorities. So what will happen? The transformers, the authorities are having what always they think as the minimum replacement items or minimum standard items which can be immediately easily replaced. So for any residential towers, the transformers owned and maintained by the authorities should be multiples of 500 kVA. So when you are arriving a load of, suppose a overall load of the project is 2000 kVA, the number of transformers comes into the picture is 2000 divided by 500. That means if the load of the project is 2000, 4 numbers of transformers you will get it. If the load of the project is 5000 kVA, you are getting 10 numbers of the transformers. This is the simplest calculations which you have to do it. So this is how we will arrive on the transformers. Second thing is location. at the ground level, where it should be immediately access to the driveway. It should not be kept where inaccessible space. I always look at the architects where they want to utilize the maximum for the highlighted units, and they want to throw all the services to the unutilized or unoccupied spaces, where if this should be immediately to be access to the driveway where a replacement is required, and it is to be maintained by the authorities. So when we again, there is the principles here when it come to the residential design. Two types of systems are available. One is outdoor installation, which I have shown in the top picture, where the transformers, the pole structures, everything is outdoor type. And next to the residential, if you are seeing from the balcony, you are seeing this kind of installation. Second is a compact substation. Compact substation is nothing but all these elements box it within an enclosure. So the second picture which you are seeing in yellow color is a compact substation where all left side, whatever the pole you are seeing on the top, and the transformer in the center, and the right side box, whatever you are seeing, all is clubbed in a box kind of enclosure, which can be kept next to the driveway, and it shows nothing will be visible. Even if you are seeing from the balcony also, it is a box which you are seeing it, and all elements are packed within the box. So this is called a compact substation for a residential design. Next, similarly, a backup generator always we will consider for the residential also. This can be either you have to give a backup to the apartments. Few things is few projects they will call for 100% backup, like all your air conditioning, geysers, whatever the load. Suppose if you are considering 10 kilowatt on the apartment, 10 kilowatt as a generator backup. That is a premium kind of segment which we talk about it. Few segments which they talk about is a small power and small minimum lighting load. Lighting load in a small power, lighting load, full lighting load of the apartment. Apart from that, your small power is your 6 amp sockets or otherwise your TV sockets, whatever it is, those things will be connected onto the generator. The third one is don't give any power backup to the apartments, only the common areas you can consider under backup facility. These are the three modes of distribution for the backup power. So this is what we can consider on the residential design. When we are going with the transformers of 500 kVA, ideally I suggest you to go with the generators also, multiples of 500 kVA based on the load requirement. So the locations, ideally, I have explained to you what is the generator locating outside or inside the building. The same principles will work here also, but the numbers is definitely multiples of 500 because the transformer capacities are multiples of 500. So this is what I have explained to you. The noise level is the principal guidance factor, and the generation exhaust stack, that is the sulfur dioxide, the black smoke, whatever coming out of the generator, need to be exhausted above the ground level. So this is how need to be considered. And fresh air and hot air exhaust for the DC sets is one of the driving factor. So this is one master plan where I am just explaining about it. Having three towers basically, the tower 1, tower 2, and tower 3. So where the trafo yards for the three towers individually got distributed. One trafo yard for the, this is a good point, a good landmark project which I'm just explaining about. This is called UBCT in central of the Bangalore, where it is a very prominent place where anybody who are traveling to the Bangalore, first of all, they would have seen this place. This is the mall kind of it. Front there is a mall, and this is an apartment, which is a high-rise apartment, which is of 38 floors, and this is a hotel. And this is a hotel. So these are the three principal entities within the same project. So what we have done is for the mall, there is a transformer yard and a DG yard, and for the apartments, there is a trafo yard and a DG yard, and for a hotel, there is a separate trafo yard and DG yard are located within the boundaries of the particular entities. So same another project which is, suppose I bring all these equipments within the basement. This is the generator area, and this is the panel room area, and this is the trafo area. It's all located in one particular central location where it is distributed to the all utility requirements of the project. Next, metering panels and communication rooms. Always it is have to have at the ground level only. Meters are LT meters for any residential distribution. Changeover and EB to DC or DC to AB, it happens through the ACCL. ACCL is nothing but automatic current changeover and limiter. Changeover and a limiter. What is this limiter? The first premium apartments you are giving 100% backup from EB to DC. There is no limitation is required. But when you are changing from the medium segment where you are giving a lighting and small power, a limitation has to happen. Suppose on the EB side you have taken completely a 10 kilowatt load, and on the other side when you are on the DG you are talking about a small lighting and appliance load. Whenever the DG is on, your current should be limited to that particular apartment to the small power and lighting loads only. This particular equipment will limit that load whenever the EB to DC or DC to EB changeover happens. So the current limitation, that is what I said. There is a 3 ways of doing it, and any electrical room when you are considering it, few precautions. What you need to do is there should not be any wet area above or below the electrical rooms. Above or below the electrical rooms, no wet areas like your toilets or your sumps and pumps rooms should not be located above or below the electrical rooms. And for each low voltage requirements like your communication or your telephone, data, voice, whatever it is required, a communication room should be considered within the basement, within the ground level. So this is a principal distribution. Because of the shortness of time, I'm not running through all these things. This is electrical consultant will take care of it. And the common and for both commercial and residential design, as I explained to you, few things other than whatever I have explained, the few things is the infra carriers. So within the floor plate area, what you will get it is the for distribution of the floor power requirements, you will be having a shafts. Those shafts are taking care of your power requirements, like your electrical rising mains or electrical cables from the ground floor electrical room to 20th floor electrical room or a 20th floor apartment. The power has to be supplied. For that, you have to have an infra requirement like shafts, power shafts. Similarly, communication requirements. When you are getting a Hathway or Stiffy or whatever the data requirements, you are getting a signal at the ground level. It should be distributed at the floor level. For carrying those cables, you should have a communication shaft. And the third one is any building. The protections are requirement. One protection which I have explained to you earlier is a lighting protection. The third one is any leakage. Suppose any conductor damage or any leakage is happening within the apartment. For any leakage, the protection is active. So you should properly empty all your electrical equipment. So the active conductors has to go to the ground or to the basement, for which a carrier is required. That shaft is to be provided within the building design when you are doing it. So lighting, I think so. I will take again lighting as a separate presentation, because within the short of 1 hour time, I cannot cover the lighting requirements. Definitely, we will log in one more time for the lighting. Principally, these are the lighting requirements when we talk about within the building. That circulation areas, you have to maintain a lux level of 150 to 200 lux level. The lobbies are the main entrance point, main focal points where you require beautiful and aesthetic lighting, and more intensive lighting is required in those areas. So we design 300 to 500 lux levels. Plant rooms are nothing but your electrical plant rooms or water treatment plant rooms or machinery plant rooms or HVAC plant rooms should be designed from 150 to 200 lux level. Car parking areas, wherever your basement car parking areas, it should be designed between 20 to 50 lux level. And toilets, banks, wherever you are having it, it should be designed for 50 to 150 lux level. All your external lighting, whichever all peripheral lighting, should be designed for 5 to 20 lux level. So this is how the lighting design is within the basement. So whatever the lux levels which I have specified about it, 20 to 50 lux level should be maintained. What is this 20, 30, 50? Somebody will get it right out. What is this 20, what is this 30, and what is this 50? 20 is the minimum lux level should be maintained in any habitable areas within the basement level. 20 is the minimum lux level, and 30 is the average lux level, which minimum to maximum the average lux level, and 50 is the peak lux level, the highest maximum lux level need to be maintained within that one. So what will happen if you take about the residential or in a commercial, the movement timings are very, very predefined. Like your morning, all people will enter. In case of commercial, the people entry will happen in the morning hours and exit will happen in the evening hours. But in the residential, it is a reverse application. All exit will happen in the morning hours and entry will happen in the evening hours. So principally, those timings you require the maximum lux levels, but whereas the off-peak timings, like between the 10 to 5, it is a requirement based on the habitable spaces. So those times you can maintain a minimum lux level for having a better energy efficient buildings. So this is where we will do with the timers. During the peak time, full lighting will come into picture. And during the half peak times, you can make 2 or 3 segments kind of it, where your fixtures will automatically switch on and switch off to maintain the lux levels within the basement. So lighting design for the staircase and corridors. All staircase and corridors are the emergency egress paths. So you should be properly lit, and all the light fixtures which are there on the staircases should have an emergency backup supply. So these are the emergency staircase corridor lighting design. And external, it's purely a facade element where you have to aesthetically highlight the building different ways. Your facade architects or otherwise the landscape architects will provide the intent required to highlight the buildings. So these are the ways of doing it. It purely to meet the LEED standards also, and it should be that you are focusing the building and you are making the building as a focal element. Briefly on the automation, this is the principal subject where automation to be looked in. Automation is the piece to design for the comfort and to design for the safety. And automation, by doing automation, you have to have a better energy savings, and automation to provide security and flexibility in terms of expansion whenever you want to add a new element. This is the automation things in respect to lighting. Why I am highlighting this particular subject after the lighting is principally automation will be looked for more for the lighting. So this considering the automation with respect to the comfort means you have to have a light fixtures with respect to the mood of within the apartment, within the room kind of it. Safety means yes, emergency light fixture should be switched on when the power failure has to happen, or a person has to reach the egress path, whatever the emergency requirement. That is the safety requirement. Energy saving is what kind of light fixtures you are going to use, and you should be talking to the automation system to switch on and to switch off or to reduce the lighting intensity. And security, yes, where the light fixtures should be provided and where the light fixture should be automated. And flexibility is to add and delete the fixtures whenever it is required. So that is the kind of integration between the automation. This is the whole, when we talk about the residential system, what and all you can bring it onto the automation is clearly displayed here. You can bring the curtain control, you can bring in the lighting design, you can equipment you can control through the automation, you can switch on and switch off the equipment based on the timings. And audio systems you can automation, home cinema you can automation, home cinema, home theaters is nothing but lighting and your projector requirements can be automated. Media centers can be automated, securities can be automated, and you can plan for keyless entry, whatever you are having a keyless features or human touch, where you can minimize it, where you can bring it onto the automations. Intercoms can be automated, your air conditioning systems can be automated. And for all doing this, the principal guidance factor is that it should be entertainment and it should be convenience. You have to look into it, and it should follow all environmental requirements, aesthetics, securities, information, communication. Nothing compromising on anything. Your automation should function, and it should have a minimum complicated features. That is what we have to consider. So this is what I have explained, automation with respect to equipment, security, what and all, entertainment, infotainment, or energy management, and central control. So coming on to the basic, again onto the earthing. lighting, as I am explaining to you, I will talk to Vani madam and I will just get one more slot for the lighting presentation because that is also a big subject which I didn't want to put more and more into your today's presentation. So earthing is again an analytical subject. All your leakage, this is a safety feature which need to be considered. I will design the building. Few of the architects will. I'm not blaming anyone, but it's a greedy is from the developers where you want to extend the building up to the compound walls. The basements you want to extend up to the compound walls, leaving the 2 meter, 3 meter setback spaces, and you are not giving any space for discharging any leakage elements or any lightning. Whenever it strikes, it should be immediately to be connected to the ground. So whenever you are planning a master planning, a few space you have to dedicate for the earthing requirement, which is for the safety of the humans and safety of the building also. So this is the earthing which need to be considered for any building. And next is that there will be a different type of aspects which electrical consultant will explain. But principally, when you are designing a building in a rocky areas, what will happen is rocky areas you cannot excavate much. Normally, any earth pit requires 3 meter deep. So 3 meter deep excavation in a rocky area is a big problem. So what alternative available to you is a chemical earthing, which can be drilled with a bore, which can be a drilled like a 100 mm drill. They will make it and they will put chemical compound to get the safety to the building and safety to the humans in rocky areas. As I explained to you, lightning protection system is a safety to the building and safety whenever we are talking about a high-rise building. Okay, I want to add one more point here. Somebody will say, I'm designing only a 4-story building in a open area, like you are not having any 100 meters within the 100 meters area, you are not having any building, but you are doing only a 4-story building. Sir, is it lightning protection is required only for a specific height, or it is lightning protection to be provided for all the buildings? If there is a tall building next to your project, that tall building is the more affected area for the lightning strikes. If it is a 100 meter or 200 meter, you are designing a building, and it doesn't have any tall objects within to that area, there is a very possibility of hitting a lightning strike on your building, even though it is four floors height only. How a lightning will strike on a tree? Tree is not a high rise. Tree is not beyond 10 meters or 12 meters kind of it. But they always you will be hearing a lightning strike hit on the tree. So that is principle is if you are not having any tall structures around the building, even then it is required to provide a lightning protection to safeguard the building and to safeguard the people within the building. So this is how the lightning protection analytical consultant will design. You will be seeing a drop from the top to the bottom of the building. This is the new code which is implementing in the electrical consultancy lightning protection design. These are the down conductors. The down conductors should be brought on the external facade between your glass elements, or a groove to be maintained from the top to bottom, where you will get the down conductor and it will be connected to the earth all around the periphery of the building. This is the lightning protection principle which need to be followed in building design. So now next is the sustainability. How much we are bringing the renewable energy into the picture. So these are the renewable energies. Normally you are having a solar, you are having a wind, and the most efficient system today is proven that the solar system out of the all renewable energies. So the renewable energy people will go with a solar requirement. In Tamil Nadu, there is a specific GO is there where you are 33% of that terrace space should be allocated for the renewable solar energy. That is a mandatory requirement in Tamil Nadu. And all other states are also driving towards that. So the terrace spaces mostly we are utilizing for the renewable energy. Solar panels to be installed on the terrace level. A brief guideline is for every 100 square foot, you can generate 1 kVA power through these solar panels. If you are suppose having a 1 lakh square foot building terrace area, 30% is 30,000. For 30,000, you can generate a solar power of 30,000 divided by 100, which comes 300 kVA power you can generate through that. And that will be used for your internal building requirements. If surplus power is available, you can export to the other items where you will get the subsidies in your building consumption. So this is on the solar power and different types. Architecturally, you can bring any type of element. If you are seeing on the top picture, this is a street lighting. What we are doing is backside you will be having a solar panel, front you will be having a light. This is different methods. You can bring a lot of architecture onto these elements also, where you can just beautify the process. So adding to the few things, maybe I'm just extending maybe a little time. I will not take more than 5 to 10 minutes of the time more than this. So new innovations which are coming into that is what is the green energy which we can utilize, like not utilizing more solar power. It is like a fuel cell technology where gas will be whatever the gas now today is available in the infra network and all city master planning. So that by using the gas, how the power can be generated without having the generators and again utility like transformers and all those things, the gas can be converted into an electrical energy that is called fuel cell technology. And next is, this is an interesting subject. To reduce the speed within the boundary, within the compound wall, all along the driveways, you will be providing a speed breaker. When a vehicle passes through onto the speed breaker, you can generate an energy with a compression, whatever it happens on the speed breaker. So that kinetic energy can be generated as a potential energy and can be utilized for the building utility requirements. And this doesn't cost you much. And this is one of the innovative component which can be thought of and which can be brought into the project. And this is not a brief presentation from my end. I hope so. I have not bored you so much and not got too depth into the electrical system. I think this may be useful for your future projects. I can say only one word: projects. Whatever we have completed demonstrates what we know. The whatever you are displaying as an architect, this says what you know on the project. And future projects, whatever present projects, it gives you this experience, and future projects decides what we learned from our previous experience. I hope so. I have given whatever the minimum good input to you, and I will be open for your question and answers if it is there. Thanks so much for giving this opportunity, and I will be interacting with you if time permits. If one means or permits, I will come back to you on the lighting presentation. This is on the electrical distribution system. Thank you so much.
Thank you, sir, for an in-depth explanation from the load calculation to designing an electrical design for commercial and industrial buildings, especially relating it to the point of view of an architect and also giving solutions for the same. Also, introducing us to the new innovations in the industry. The topics you explained were in par with the students' study in their 5th semester and above, and also very useful for their application in their academic projects as well as their practical application. Now, to the audience, the forum is open for question and answer. You can either voice out your questions through the mic or even you can type it in the public chat box. We are open for questions.
So one more thing. I think you are all now in shocking mode. Okay, I will just give you before my next week. My colleague comes onto the board, so we will give the presentation. I will give to take you from the shock whatever I have given. I want to, if no questions are from your end, I just want to make some funny moments in that. Okay, I will give you one case study. Okay, this is not related to anything electrical. Talking about it, there is one question come up. Are there any minimum sizes for the shaft for infra carriers? Also, can you please suggest standard sizes for the metering panels and communication room for both residential and commercial buildings? It's a good question. Good question. What you can do is the shafts sizes, it will increase. Whenever you are doing multiple shafts you can minimize it anytime based on your spaces which you will get it next to your staircase areas or next to your lift areas, you can minimize. When you are talking about a centralized shaft, two types of problems will be there. Connecting all the apartments connections up to that centralized shaft, and shaft width and depth also will increase to accommodate all the pipes within the shaft. There is no standard sizes. Standard size with respect to the depth you can fix it. The depth can be minimum size, minimum of 300 mm. You have to keep it for running your pipes and all those things, and to have easy maintenance wherever you are getting the openness. Depth is fixed, but the width is always how many shafts you are giving it. How many? If you are giving more shafts, the width can be minimized. That is one thing. And the standard sizes of the metering panels. Metering panels, as per Tamil Nadu, the maximum 20 meters will be connected to one panel. So if you are having a 240 apartments, so you have to have a 12 metering panels. So 12 metering panels located depending on the project, depending on the volume, the number of meters, but principally the 20 meters will be connected onto each panel. That is the one guidance. And communication rooms, yes, communication room will come, one centralized communication room at the ground level. That communication room, you can take it as a standard, says 2.5 meter by 3 meter kind of it, where all your incoming service providers connections will come and terminate. From there, the distribution going to start for the individual floor levels.
So you were telling about the case study.
Yeah, this is a funny case study. I'm taking you all now, whatever the boreness which I have given, I just want to take out of that board subject, whatever electrical subject. This is a case study, just a funny case study, which I'm just explaining to keep, again, being a Sunday, I don't want to, this whole day should continue with this boring lecture kind of it. So what I'm just explaining to you is one case study, funny case study. In between Delhi to Jalandhar, when a person, I'm traveling on that particular road, I saw when I'm doing some studies, I found that more washing machines are procured in that belt between the travel to the Delhi to Jalandhar. I see more and more utilization. Like one of the washing machine company has studied it. Yeah, my maximum usage, I'm getting more selling a washing machine in this particular road. So they found out, and they have done some studies on that. They have sent the people, like one of the washing machine manufacturers sent the team there. Why more it's happening there? Why more business I'm getting in that particular business? After doing that study, immediately they have stopped and they've told to the sales agents not to sell any more washing machines in that particular area for the usage what they are doing it. Do you know why more washing machines sell in that particular segment? Anybody? So I'll tell you. There are normally you see any from Delhi to Jalandhar or Delhi, any Punjab areas. What is Punjab more specialized for? Dabas. You will be having more dabas, more beautiful food there. So what Punjabis will more drink? They will drink lassi. Lassi is more. So when travelers are more, when they have to make more and more production of lassi within a short time, when a bus arrives, they have to produce 50 lassis, 100 lassis within a short time. Instead of running more and more number of mixes, they are putting curd in the washing machine. Switch on. Within 5 minutes, you will get 100 lassis within no time. So washing machine principle is to machine to wash the clothes, and they are using for producing the lassis within short time. So what is the main? If I am a competitor for that particular company, what I will do? This washing machine is suitable only to make lassis, not for washing machines, washing clothes. So this is a beautiful case study. So any item, Punjabis are, that is why they will always called as the cleverest people in the world. So they have found out one good machine within 5 minutes I can give you 100 lassis. Not with the mixes, they have done through the washing machine. This is the funniest case study, which I just want to come out of the mood, whatever the bonus lecture what I have given to you. Thanks to all. If any no more questions, I really thankful to the management. They have given me the opportunity, and I wish you all the best, and I want to work with all of you in future as an electrical consultant. Thanks so much. You are the creators. Thank you.
So there's one more question.
Yes, sir.
It's there. It's from in the public chat. Like approximately how much area do we need to dedicate in the master plan for earthing for a multi-story building campus? And are there
Yes.
any?
Sir, I will answer this question. See, a thing is like if I talk about any commercial building, normally what will happen is individual floor-wise tenants you have to provide two earthquakes. So any earthing always called as a double earthing. In case of even one fails, there is a second line should be available to get the protection. So for any floor, if suppose you are having a 10 floor building, a commercial building, every floor minimum you should have two earthquakes. So that means 10 into 20 numbers of earthquakes. Normally, earthing, what will happen is as a earth pit, individual earth pit, it won't take more area. That requires only a 450 by 450 mm space at the ground level to have a chamber, open the CI cover, and to pour water inside the earth pit or to provide any chemical, charcoal, or anything to add to that particular earth pit to get the better efficiency values. 450 by 450. But what will happen is either you should align all this in one line. The mandatory requirement is you should have minimum 3 meter gap between one earth pit to the other earth pit. So either you can provide in a linear structure by giving a 3 meter gap between the earth pit to earth pit. That is one way of doing it. Or you can do a 2 row module or 3 row module by giving a 3 meter gap between the between. This purely depends on how the master planning is happening. Today's infrastructure, whatever I am seeing, by leaving a 2 meter space between the compound wall to the basement areas in few of the states. So I have to arrange all these earth pits in a linear fashion by giving a 3 meter gap from earth pit to the earth pit. So this is the code is IS 3043 is the code which defines the gap what to be maintained between the earth pit to earth pit. That is the 3 meter which is as per the coral and standards. Why that 3 meter is not to have a circulation current. Suppose one where you are dissipating lightning strike has happened, you are dissipating the earth to the earth, and it should not come a path like to the again. If you keep near the vicinity one more earth pit within a meter, that will become a conductor to again a circulating current. Not to have a circulating current, a minimum gap of 3 meters should be maintained between the earth pit to earth pit. I think more messages below. Okay, Mr. Prabhu has asked, sir, looking the specification of any lighting devices, can we arrive at the lux level or is there any formula? Yes, we can definitely specification of lighting device. Lighting devices will not make a part of lighting device is one part of the calculations. Lux level is the predominantly first you have to fix it. What is the lux level you are achieving? Suppose if you are taking one meeting room, the meeting room lux levels are defined. Based on the lux levels, all the specifications like what type of lighting fixture we have to select it, what type of color temperature we have to select it, and what is the other elements which are influencing like wall reflectance or floor reflectance or a ceiling reflectance. These are all part of the calculations. Next is coming on to the Arun's question. You can briefly explain about the underground power cable laying. Is it advisable to provide underground cables in place where the rainfall is more and prone to waterlogging and flooding? See, any temperature, if you are maintaining anything, if you are coolness, normally whenever a current passes through a conductor, there is always a heat will be developed because of the internal resistance of the conductor. So it should be dissipated. It should be dissipated. There is a water clogging. There is no problem. You have to protect the cable. That's it. When you are how you will protect the cable in a waterlogging area is run through the fume pipe or run through a cable channel or a cable duct where it will be physically intact. Adding if the water comes in close contact with the cable, with if any damage is not there, there is no problem. And a wet soil all around the cable laying is a better your dissipation of the heat to the surrounding areas. So that doesn't hamper anything. But because of soil erosion or because of some soil lying, slowing, and all those things, your cable should not be disturbed. For that, what we will run through is we will run through a cable duct or otherwise a tube pipe.
So I had a query. This is regarding these projects. You were showing us the Bangalore projects, and you were showing us the yards which were placed between these buildings. So, so I just wanted to know whether like this is where you have some land available, and you are working with a very commercial client. So the client would also be demanding that, okay, you are taking up a lot of area which is going to be, kind of a commercial sellable area for many cases, because you are practically, you cannot put anything next to it. You cannot have a, any usable space next to it, because it is a risk in case of any fire or any, electrical damage that could happen. So I just want to know, regarding your own experience in projects, what was the, the tightest site or tightest location where you were kind of bound and you had to provide a transformer yard or a DG set? What is the minimum distance that you had to go with in a certain situation?
Sir, always see next to the one good part what is happening in the pipeline is you have to have a driveway, fire driveway next to your building. That is the minimum requirement as per your fire regulations and as per your BBC codes and standards also. Your fire driveway should be next to the building. So your any equipment will come after fire driveway only. That means mandatorily the fire driveway is 6 to 7 meters. You are keeping a 6 to 7 meter from the building for the electrical installation is always the safest factor. So that is with respect to the ground clearance I'm talking about. So electrical system is nothing but a nerves in our body. Electrical system is definitely required to function all elements within the building. We should not forego that electrical system should not be visible kind of it. We will always talk to whenever we are talking to the developer and when we are talking to the any architects also, we will always tell to them this is required for function of the building. Any element within the building to function, electrical system is required. You don't have any invisible system where you can give the power to the building. So few of the elements architecturally, I told both outdoor and indoor, I have given few justification how you can beautify the project, but without seeing anything, if you want the power to the building, it is not at all possible. That is always I will tell to them few of the things you have to consider as an architect for giving a power to the building. So regarding the spaces, yes, the dry type installation, indoor installations, whatever it is happening, it can be next to any parking spaces because all are very well taken care of within the room kind of it. And external, it should be away from the building. Either it should be separated by a fire driveway or a minimum gap of 5 meters should be maintained from the building line to your any electrical installation.
Yeah. Thank you, sir. Thank you.
Oh, morning, Mr. Mitra.
Good morning, sir.
Very good morning. How are you?
Fine, sir. Doing good, sir.
You were Vijayawada, Hyderabad, I mean, now Bangalore, Kolkata, Chennai. Where are you now?
Sir, I'm located in Bangalore in head office.
Bangalore.
Yes, sir.
Okay, so you're all there in head office with Mr. Reddy there.
Yes, sir. Correct.
How is his health recovering?
He's doing good, sir. He's doing good right now because of he's our principal. Actually, he is having that enthusiasm to do more and more and to make the company in a better prospects kind of it. So because of his extensive travel and because of his more involvement, there is a little hurdle has happened now. Now he's recovering very well, and soon he will be back onto the board, sir.
I'm not even disturbing him over these calls, except for those initial dialogue with him to set the tone of this webinar series, which is magnanimously accepted. And then he had put me on to Mr. Karthik Bad, and then it is moving quietly and progressively and beautifully, on to the rest of you people, moving from HVAC to electrical. It's all going good, so wonderful, and I don't think I can ask for anything more than whatever you have presented, starting from 11 o'clock to 12:18, close to an hour and a half. I just have one request, not immediately. Once your electrical and HVAC, electrical, plumbing, firefighting, and building automation and structure gets through, with your basics to be communicated to the architectural student, I have one request which you can think through or discuss internally. Even Mr. Reddy, I'll also speak to him. In fact, my chairman is also having every time when you are finished with your webinar, I make it as a ritual to get you all connected to speak to them and tell them how beautiful the values are getting added from your experience to the students. But still, I'm still not happy with the crowd which is logged in. It was just about 70 plus, wherein the strength is more close to 300. So something is still going wrong with the students. Is it because of a Sunday or is it because of lack of enthusiasm? But otherwise, all the faculties have logged in. My HOD is always spot on. He's always there, the first person to log in and the last person to log out. I only, wish my students learn from them, and of course from my other faculties. Arun Davis is one of my senior, faculty who is always spot on in terms of asking the questions, learning from it. He will never shy away. But the request which I'm planning to put across to you is, I've dealt with you during your potential days with Mr. Reddy and all your Prasanna, everybody. And we've been having this discussion with the services consultant and structural consultant. The area where they lack, the area where they normally do not understand us, sizing of, it was nice of you to, give us an insight of starting from your substation, then to a trafo yard, and then to your DG, and then to your panel rooms, and then the distribution. Spot on, wonderful, brilliant. Likewise, the same thing has happened in HVAC as well. But the area where the students and the practitioners fail is in sizing them and locating them and calculation of that. The numbers and the size of each number, whether you call it an electrical meter room or the communication panel room or the DG room, whether it is an indoor outdoor, they normally fail. You have given us an insight on calculating fairly the sizing, but then when it comes to a project, depending on the size of the project or the load of the project, how do we go about networking each of this specialist requirement in terms of the size of each of these requirement, in terms of the number of each of the. I think the number was fairly spelled out, but the sizing of it, how much will the spatial arrangement for each of those, if you can run through in one seminar or a webinar, whether it is an online or offline, starting from HVAC, moving on to electrical, then PhD engineering, it'll be great. That'll be one complete webinar where we pull in this HVAC requirement, we pull in this electrical requirement, we pull in this plumbing health engineering requirement, and take the students through in terms of the spatial allocation for each of this, including maybe whatever you had spelled out, those 4 broad parameters. I want them to get equipped in sizing that. Location you are dealt with. The sizing, we may have to take one webinar a little in detail if it continues in online mode, or maybe I'll have a request to have you all here in Ooty, take it as a vacation or a break. At least a few key people. I can ask Mr. Reddy if he has time and the energy and the health would permit him to come to our campus. But that will be my last request, but not immediately. And once you all finish through your 7 or 8 webinar series, which is lined up. But otherwise, it was spectacular. The simplicity in which Mr. Karthik took the HVAC lesson through, and the way you took the electrical through from start to finish was really very simple, very enriching. Even after all these years, I'm still want to sit through and enjoy the conversation, the dialogue between you and my Sanil and JP and the rest of the faculties and the students. But still, it was wonderful. But I will leave it to you and Sanil Mitra.
Thank you so much, sir. Thanks for your really nice words. Basically, yes, really one webinar actually on one live project. Definitely, whenever the time permits, when the students are ready. So what we can do is we can just make one project. Let us take it as a residential project or a commercial project from the start to the end of it. We can run through a session where how to size the equipments, how to place the equipment, and what are the conditions need to be considered while placing the equipment or while sizing the equipment. This all we can run through, and we can do one workshop kind of it where It will
That would
be
be
very
great.
helpful. Very helpful. Let us, instead of individual, everyone brings one new project. One project as one model project, we can take it, which Synergy has approved. So that particular project, we can run through all the subjects and we can explain them, yes, what and how to consider the equipments and where to, what are the advantages, disadvantages. We can run through the workshop. It will be very helpful to them. And
Oh.
I really want to do this one because tomorrow when they are out, when I'm working with them, at least if they have the fair idea, my job is very much reduced. So I'm with you, sir. Definitely, we will do that one. It's a good initiation which you thought of, and we are very much okay with you. We can do that one when the time permits, and we will do it, sir. Definitely, we will do it.
I would love to have you here in the campus when the pandemic fairly subsides. Take a kind of a break, maybe not more than a day or two. You can just stay for an overnight. You and the team. I'll request Mr. Reddy also, if it permits, and it'll be great if Sanil can organize it in an offline mode where the students are there, about 300, 400 students. It'll be amazing. And I don't know, maybe we can look at it as a kind of a symposium. I will leave it for Dr. Sanil to run the program through in consultation with you, and of course, Vani also. A kind of a symposium where we call people from all over the state. We are about 90 plus colleges, Mr. Mitra. Imagine the 90 plus colleges, even if you're putting in an average 10 students from each, it is a huge number. If we can conduct one symposium or a workshop in a regular mode where we demonstrate a live project in those various services, starting with HVAC, the same way I'll follow your same flow, HVAC to electrical to PHC and firefighting and BMS, and preferably structures also, and give the students the kind of a design program. How does this various services affect them in the spatial planning will be the most brilliant workshop. I don't think it has ever been conducted by any of the other architecture schools.
Yeah,
And,
really, it's really nice of it, sir. This is what this generation of students is getting. Actually, even the managements are thinking of it, and the lecturers and the HODs, they are all giving this opportunity to them, basically to learn, to have the practical exposure. Whereas in our age, basically, we don't have all these facilities, and it is a good initiations by all the colleges, and it is good initiation, especially by your team. Really nice of it, and definitely students has to utilize this to the maximum extent, not just be like ignoring things. And we are always with you, sir. We are ready to share our experiences with all the stakeholders and with all the team members, and if they can maximum whatever they as I explained to you, whatever the maximum which he can a Punjabi can get through a washing machine, they can extract from us. We are open to that.
I will leave the choice with Dr. Sanil whether to, we don't know for sure how long will this online continue. If it is going to be yet another semester, then I'll look at as an online webinar, online workshop or something. But in case if it subsides and the students are asked to come in person by the universities, there is a green signal, then I would love to have it as a offline symposium or a workshop, and particularly to see you all in person.
Sure, sir. Sure, sir. Always obliged.
Thank you so much, Shripad. Sanil, please.
Now I call upon Dr. Sanil Kumar, our head of the department, to deliver the vote of thanks.
So anyways, it's a big honor, sir, that you could be part of this particular event and you could take time out on a Sunday to talk to all our students. And I've invited all our faculties, the faculties who are teaching building services and building materials, to be part of this particular talk. And we also want them to collaborate with you. We also want them to kind of get you in the process, get you to be part of our studios in the future. In the near future, we would have again more of these interactions. Again, this is a part of the series that we are continuing, but it is a big honor for us that you could take time out. I thank you, sir, from my side and from the institution side, and I'm glad that all our faculties could benefit and they could raise questions to you and they could find more information and more interest in pursuing this. So I'm expecting now more faculty, initiation and faculty participation in building services workshops, which we could have, building materials workshops, building services workshop, and to make it more critical for students to understand the involvement of working with consultants from various fields, because this is one thing which is more and more required, that architecture has to be understood as a collaborative process. And that is why I'm glad that you presented the discussion from the side of, you're talking about electrical components as a viewpoint of the architect, so that makes it really understandable, very legible for them to relate to it. And I'm hoping that the studio discussions from tomorrow onwards, Dean sir has already talked about it, so from tomorrow third year and fourth year discussions would be more critical. They're doing urban design projects, and they're doing projects for institution, an IT office as well. So I'm expecting now tomorrow, when the critique sessions begin in the studios, they would be much more inclusive of the two workshops which have happened over the last 2 weeks. So thank you, sir, for taking time out, and I thank my dean, and I thank Professor Jayapriya Professor Vani for coordinating this event and conducting this webinar. And I thank all the participants, all the staff members who have been part of this particular event. I thank you all for being a part of this. And I'm looking forward to much more discussions and much more collaborations. And thank you, sir, for the suggestion. I would be
Thank
getting
you
in
so
touch
much,
with
sir.
you. Thank you, sir. I
Thank you
would be
so
getting
much.
in touch with you. I would be getting in touch with you separately for upcoming discussions related to this.
Sure,
Looking
sir.
forward.
Always
Thank you, sir.
welcome. Always welcome.
Thank you, sir. Thank you.
Nice, nice.
Thank you, sir. Thank you so
Thank
much. It
you,
was
sir.
an
Thank
honor,
you.
sir. Thank you.
Thank you. Thanks to all. Thank you so much.
Thank you, sir.
Thank you all. Thank you.